This flip is about buoyancy. How can a steel boat float? We learned that density is the amount of matter or mass in a given space or volume. For example, a soccer ball contains mass. I will show mass by these dots that represent molecules. So these are all molecules that make up the soccer ball. And we'll just say that's as many molecules in that soccer ball. Now let's look at a bowling ball, which takes up about the same amount of volume or space as the soccer ball. When I put in dots representing the molecules or mass of the bowling ball, I would have to put in a whole lot of these because we know that a bowling ball is much more dense. Lots of molecules in there. We know this because we can feel gravity pulling on the mass of the bowling ball, and the bowling ball is much heavier than the soccer ball. We can kick the soccer ball, but we better not try kicking the bowling ball. So the bowling ball has a greater density than the soccer ball. Now let's look at buoyancy. Buoyancy is the ability of a fluid, either liquid or gas, to exert an upward force on an object immersed in it. This is somewhat like the normal force your chair is exerting upward right now as you sit in it. So if you were to drop a piece of wood into a cup, it will sink only part way. We'll make this wood red. It will sink only part way in the water. This is because of Archimedes' principle. The upward buoyant force on the wood is equal to the weight of the water displaced by the wood. Let's say that again. Archimedes' principle is the upward buoyant force on the wood is equal to the weight of the water it displaced. So the water that it displaced is actually in this purple area right in here. And that water is going to be much more dense and weigh more than the block of wood, which is quite light and less dense. Since the wood isn't very heavy or dense, the weight of the water displaced easily equals the weight of the wood and it floats. Conversely, if you drop a steel block into water, let's do that over here, the steel is very dense and heavy, and it will weigh more than the weight of the water it displaces. It weighs more than that amount of water, and so it sinks. Why do boats float? Well, how can a steel boat float? If the boat was solid steel, it would be very dense and heavy and it would sink right to the bottom. But the boat is full of air. We'll say all these are air molecules in here. And the air is not dense at all compared to water. The boat itself displaces a lot of water. Let's put some water in. So all of this area down here is water, and you can see that it is displacing this much water. So the boat displaces a lot of water, and the weight of the steel hull plus the air is less than the weight of the water it displaces. However, what if it leaked? Oh dear. There's an iceberg, and we'll call this the Titanic. And if we got a hole in here and it filled up with water, then the weight of the water plus the steel hull would be greater than the weight of the water it displaced, and it would sink. So suppose we toss a beach ball into a pool of water. The beach ball is easily going to float, and so my question for you is to explain, using Archimedes' principle, why does the beach ball float? Okay, thank you very much. See you next time.